Okay, so this is a key to topic 21, part A, worksheet 1. And basically in part 1, you're given these quadratic functions that are written in vertex form or standard form, and you're asked to find information about those. And then in part 2, it's kind of the same thing, except now you're going to be asked some little bit to do some more information or to give some more information about these two, like domain and range and so on. All right, so let's look at number 1. So in number 1, we have this in number 1. Okay, so remember though, as we go through the process, you have to remember that this is what vertex or standard form looks like. And so your vertex is HK. All right, and so remember, when determining H is the one that causes some issues for students. It has to be of the form X minus, and then this is H. All right, and then K is whatever this number is right here. Okay. All right, so let's get number 1. So number 1, we have y equals 3 times x plus 4 squared. Okay. Now, notice that this is of that form. Now, you may say, well, there's no k there. Well, you can rewrite it. So you can rewrite this as, y equals 3 times x plus 4 squared plus 0, couldn't you? Okay. And so now you can determine h real quickly. Now, for some of you, you may want to rewrite x plus h so that it looks like x minus h. So in other words, you may want to rewrite this further, rewrite as y equals 3 times x. Now remember, x plus 4 is the same thing as saying x minus a negative 4 squared plus 0. And so now this is your h, and this is k. All right, so your vertex is negative 4, 0. All right, so your vertex is negative 4, 0. Now, the other thing they want to know about this one is this. Does it open up or does it open down? Well, remember, in your vertex form, and even in the general form, A determines whether it opens up or down. So remember, if A is positive, it opens up. If A is negative, less than 0, it opens down. Okay? And notice that in our example, A is 3. So since A is positive, so it's going to open up since A is positive. Okay? Then the other thing we wanted you to do is to determine the axis of symmetry. Well, remember, and this is important, remember when we talked about the axis of symmetry in previous lessons. So this is your parabola right here. The axis of symmetry goes right through the vertex. So if you're going to determine the axis of symmetry, it is very helpful to know the vertex. And you know the vertex. The vertex we found is this. Now notice that the axis of symmetry is a vertical line. And so to name a vertical line, remember it's x equal. A vertical line from previous courses, and even in this course we discussed this, the naming of a vertical line is always x equal. So notice that no matter where you are on this dotted line that you see, the x coordinate is always the same. And so it's easy to determine the x coordinate. If my vertex is negative 4, 0, then all these x coordinates here are going to be negative 4. So x equal negative 4 is your axis of symmetry. Now, it's very important that you understand this so you don't lose points. When you're asked to determine the axis of symmetry, you are indicated to write the equation of that axis. So just don't put negative 4. You have to say x equal negative 4. Okay, so that's important. You have to say x equal negative 4. Don't just say negative 4. All right, so that was number 1. So number 1, we know, based on this information, we know that the vertex is negative 4, 0. It opens up since A is positive, and the axis of symmetry is x equal negative 4. And then you do the same thing for all of the remaining problems. So if you look at number 2, this is what we have in number 2. We have g of x is negative 2 times x minus 3 squared minus 4. And notice that to determine the vertex, this is already in vertex form, And it's already of that form where we want to say x minus h. So you see x minus 3. So h is 3, so that's your h, and then negative 4 is k. So your vertex is is positive 3, negative 4. That's your vertex. Okay? So that's your vertex. So that goes here. Positive 3, negative 4. Now you need to determine if this opens up or down. Well, remember what determines whether it opens up or down is A. And in this case, A is negative 2. So since it's negative, your parabola is going to open down. It's going to look like this. Okay? So in your mind, that's what you should be thinking of as well. Does it open up or does it open down? So we know it opens down, so it's going to open down. So it opens down since A is negative. Okay? Now sometimes you'll see the phrase it's concave down. So sometimes you might see concave down. All right, and over here you could have said concave up, concave up. So open up, concave up, same thing. Okay? All right, now the axis of symmetry. Remember, the axis of symmetry, you have to state the equation. Just don't put a number here. So remember, the axis of symmetry goes right through the vertex, and it makes, if you look at the graph, it's symmetrical about that axis of symmetry. Okay, so your axis of symmetry. And notice the axis of symmetry goes to the vertex, and that vertex here is 3, negative 4. And so no matter where you are on this dotted vertical line, the x-coordinate is always 3. So the axis of symmetry is x equal 3. It's always your x-coordinate. But you must say x equal, so you don't lose any points. All right, so that was number 2. So let me go ahead and finish this. Number 2, it opens down, and the axis of symmetry is x equal 3. All right, number 3. So number 3, we have this. We have h of x is equal to 2/3 times x plus 5 squared plus 2. All right, so your vertex, remember, if you have to rewrite this, if you need to rewrite this, you rewrite this as h of x equal 2/3 times x minus a negative 5 squared plus 2. So that way you can easily determine that h is negative 5 and not positive 5. So your vertex is negative 5, positive 2. Okay? Now, the next part was to determine whether it opens up or down. Well, A is positive. A is 2/3. That's a positive number. So it's going to open up. It's going to open up since A is positive. So we know it's going to do this. That's what it's going to do. Then the axis of symmetry goes right through the vertex. Well, your vertex is negative 5, 2. All right, now remember, your vertex is a point, so you have to have an x-coordinate and a y-coordinate. So your vertex is negative 5, 2. So that means that, remember, vertical line. So no matter where you are in this vertical line, the x-coordinate is always negative 5. So this is named as x equal negative 5. So that's your axis of symmetry. So axis of symmetry, you have to say x equal and then negative 5. All right, so that was number 3. So number 3, we have, as our answer, we have negative 5, 2. It opens up, and the axis of symmetry is x equal negative 5. All right, now let's look at number 4. Now number 4, don't let number 4 throw you off. You know that you know how to rewrite it so it can help you. So number 4, we have negative 1/4 x squared plus 3. Now what causes students issues is that this x, that you see an x squared, but you don't see a binomial squared. And it throws students off because in the equation, they always see a binomial being raised to the second power. But when they come to this point here, they don't see a binomial. They just see x squared. Well, remember, this x squared you can write as f of x equal negative 1/4 in parentheses x minus 0 squared plus 3. X minus 0 is x, and x squared is x squared. right? So right away, you know your vertex. Your vertex is HK. So your vertex is 0, 3. That's your vertex. Right? And so since A is negative, negative 1/4 is going to open down. So it opens down since A is negative. And since it opens down, you know it's going to look like this. And you know that the axis of symmetry goes through the vertex. And the vertex here is 0, 3. And we know that for a vertical line, the x-coordinate is always the same. So the x-coordinate has to be 0. So you get x equals 0. So the axis of symmetry is going to be x equal 0. All right, so that's number 4. Okay, so let's look at number 5. Now, number 5, you're going to be asked to indicate some additional information. But let's go ahead and finish number 4 first. Number 4, it was 0, 3. It opened, since negative opens down, and the x-coordinate is 0 here, so the axis of symmetry is 0. So notice that your axis of symmetry is always the x-coordinate of your vertex. See that? Negative 5, 0, 0. 3, 3. Negative 4, negative 4. All right? Okay, number 5. So number 5, we have this. We have g of x is equal to 4 times x plus 5 squared minus 1. And you're asked to find the vertex, domain, range, and some other information. Okay, so the vertex you know how to do. So the vertex is, in this case, negative 5, negative 1. Negative 5, negative 1. That's a vertex. And remember, this is a quadratic function. And it's also a polynomial function. For one thing, you all know that the domain of a polynomial function is all real numbers. And even if you did not know it was a polynomial function, you at least know that it's a quadratic function, and the graph is a parabola, and it opens up. So it looks like this. And so remember when we used when we used the ruler, we went from left to right. So notice that I'm going from negative infinity to infinity. All right, that's domain. The range, to determine the range, you really need to put the vertex here. And so the vertex is negative 5, negative 1. Now remember, when we talked about the range, so let me go ahead and remind you, when we used the ruler, we went from bottom up, okay? And notice, remember, the range is a set of y coordinates. So when I get to this graph, the vertex is the lowest point, right? So it's a minimum. The y coordinate, remember, the range is a set of y coordinates. What is that y coordinate here? Well, that y coordinate is negative 1. So you're going from negative 1 all the way to infinity. So the range is going to be from bracket, see that's a closed circle, so bracket negative 1 to infinity. So that's your range. And then it says this for part D. So this was A, this was B, this was C, and then D. So in D, it's asking you this. Does g of x, so does this function here, you know it in your mind, you know whether it goes up or down. So draw it. It goes up. Does that function have a minimum maximum value? Well, the vertex, for a quadratic function, the minimum maximum will always occur at the vertex. So if you notice the vertex here, the vertex is a minimum point, right? Minimum point. So that means that this function is going to have a minimum value. So it's going to have a minimum value. Okay? And then part E says, what is that minimum value of g of x? Now this is important. It says the minimum value of g of x. The minimum value, that's your y value, your y coordinate. That's your y coordinate. So don't say the point. Don't say the minimum value is this point. The minimum value is the y coordinate, which is negative 1. That's the smallest y coordinate. Okay? So that's going to be negative 1. Now that's your minimum value. You indicate the y coordinate. And the minimum, for whenever you're dealing with quadratic functions, the minimum or maximum is always going to occur at the vertex, and you're always going to use the y coordinate of the vertex. Okay? All right. And then in number 6, you have this one. So it's the same type of problem, except the only difference is this. The only difference is this. So in number 5, the quadratic function concaved up, right? So it opened up because a is positive. Here it's going to open down. It's going to be concave down. So in your mind, just what you have. It's a good idea to think about it like this. So you know it opens down, right? And so let's go ahead and find the vertex. So the vertex should be easy now. So your vertex is 6, positive 4. Your domain, remember that in your mind you know what it kind of looks like. So the domain is from negative infinity to infinity. Since it's a polynomial function, remember the domain of all polynomial functions is negative infinity to infinity, all real numbers. So that's your domain. C was your range. Now remember your range. Remember this is pointing down, right? And so notice that your vertex is a maximum point. So it's a maximum point. That's your vertex, a maximum point. So notice that I'm going from negative infinity all the way to this y value right here. So it's a good idea to indicate that y value, that maximum point as 6, 4. So I said maximum point, 6, 4, xy coordinate. So I'm going from negative infinity all the way to this maximum y value, and that maximum y value is 4. So you're going from negative infinity to 4 with a bracket. Okay? Remember, domain and range, you have to think about, do I need brackets? Now, whenever you have infinity, negative infinity, you're always going to use parentheses with those. Okay, D, they ask you, let me go ahead and show you. So D says, does h of x have a minimum maximum value? All right, and so notice, since this is a maximum point, it's going to have a maximum value, and that's going to be your maximum value. So it's going to have a maximum value, so a maximum value. And then E, they want to know, well, what is that maximum value? It did not ask you for the maximum point, okay? It asked you for the maximum value. So the maximum value is a y coordinate, so that's 4. So the answer is just 4, okay? All right, so that is, and let me go ahead and kind of real quick, at least put the answer for number 5 on here. So in number 5, we saw that the vertex was negative 5, negative 1. The domain's negative infinity to infinity. The range was from negative 1 to infinity, and it has a minimum value, and the minimum value is negative 1. This one, the vertex was 6, 4. The domain was negative infinity to infinity. The range was negative infinity to 4 with bracket. It was a maximum value, and the maximum value was 4. So that was the key. That was the key to topic 21, part A.